Welcome to your first video session of notes. This is section 1.1, and we're going to start out with some vocabulary. The first vocabulary that you're going to deal with is rational numbers. And rational numbers can be represented by Q, and you may wonder why Q. And I've highlighted the first part of this word here, and it's ratio. A quotient is what you get when you divide one number by another number. So rational numbers can be expressed as a quotient, or you might want to think of it as a fraction, of two integers where the denominator is not zero. Division by zero is undefined. Now the decimal form of a rational number either terminates, which means that it stops, or it has a repeating pattern. So here we know that the next number, because of this bar over the 3, is going to be a 3. It goes on into infinity, but we know that the next number is 3, so we can predict the next digit, which doesn't happen with irrational numbers. Now, irrational numbers, there's really not an accepted letter that represents irrational numbers, so we're just going to write IRR for irrational. Irrational numbers cannot be expressed as a ratio of two integers, and their decimal forms do not terminate or repeat. So this is an example of an irrational number. These three dots mean that it keeps on going, and we can't see a pattern, so we can't predict what comes next. So kind of think about rational and irrational numbers just like you would rational and irrational people. Irrational people, you can't predict what comes next with them. Just like with the numbers. We don't know what number comes after this 8. We do know what comes after the 3. Okay, so that's irrational and rational. Let's move on to natural numbers. Natural numbers, think back to kindergarten. When you started learning, they started you out with the number 1. Natural numbers are represented by a capital N, and they are the set of numbers that we naturally count with. They start at 1 and do not include any decimals or fractions. Now, when we say they don't include any fractions, we're not talking about the case where you can write any number over 1 and you think that that's a fraction. So we're just talking about the numbers that you count with and they keep on going. Whole numbers are represented by the letter W, and they are the set of natural numbers, and then you just add a 0, and that's the only difference between these two sets. This one has a 0. This one does not. The next set are the integers, and integers are represented by the letter Z, and you might wonder why Z. Well, that comes from the German language. This is the word for numbers. So maybe think of integers, maybe say it integers, like there's a Z at the end of it to help you remember the letter that represents it. These are the set of whole numbers with their opposites added to the set. So we can talk about -1, 0, 1, and so on. Okay, and then the real number system, it would be all of the numbers up above. The real numbers are represented by an R with a little bar right here, and they include the rational and irrational. So again, that means everything that we've already defined up above. They represent any number on the number line. Now this pink line is not important. It just helps me know that I need to keep moving my paper up so I don't go off of the view of the camera. All right, now we're going to do a visual or a Venn diagram of how the real numbers can be represented. So everything in the box below is considered the real number system. Later in the year we'll deal with complex numbers, but right now we're just dealing with real numbers. We're going to break that up into irrational and rational. Okay, so let's start on the left-hand side first. Irrational numbers are numbers that do not terminate, and they do not have a repeating pattern. So the most common irrational number is pi. You can also do square root of prime numbers or square roots of numbers that are not perfect squares. And then E is another one that is an irrational number, and I'm just going to put a ... here to show that it keeps going on. We'll talk about E a little bit later in the year, but that doesn't terminate and there's no repeating pattern. Now, a rational number, we could have something like -1, we could have 0, we could have 1/3, we could have the square root of 36, which would just be 6. And we could have decimals as well. So let me just write a decimal down here so we don't think that there aren't any decimals. So 1.73, that terminates, so that is a rational number. All right, let's fill the oval in. we're going to start with the numbers that you naturally count with when you learn to count. So the natural numbers are 1, 2, 3. I'm just going to put a comma there and dot, dot, dot. When we go to the whole numbers, the only difference between those two sets is that the whole number also includes 0. So 0, 1, 2, dot, dot, dot. And then the integers would be, we're going to keep building by adding numbers. And here we add the opposites. So we're going to go just dot, dot, dot to show that it keeps going to the left. Then we'll do maybe a -1, a 0, and a 1, and then dot, dot, dot. Okay, so that's how you can see that the real numbers are broken down. Now let's go down to this chart right here, and we're going to classify some real numbers. Now I'm going to give you a hint here. Anytime on your homework, on a test, or on a quiz, and when we're in chapter 1 until we get to complex number, every number that we're talking about is in the real number system. So one thing, no one should get this wrong. Check real numbers for everything. All of these numbers are real numbers. We don't have any complex numbers, so they're all real. All right, now we're going to take 8 and divide it by 4, which gives you 2. Is 2 a number that you count with? Naturally, yes. When we count, so again, think back to kindergarten when you're counting, you don't use negative numbers when you're counting or decimals. And this would be 0. And again, you don't start with 0 when you learn to count. You start with 1. So we're going to skip over that. Oh, and it looks like I need to take that last one off. I said it was not a natural number, and then I checked it anyway. So we'll just take that off. That is not a natural number. 0 is not a natural number. Pi is irrational, so it's not a natural number. 23, if we kept counting, this would be a natural number. And negative, because of the negative, is not a natural number. Now let's go over to whole numbers. Anything that's a natural number is also a whole number. So this is a whole number. Whole numbers do not have decimals or fractions, so this is not. A whole number includes 0, so we can check that. This is irrational, so we're not going to check that. Whole numbers would include 23 because it's your natural numbers, all the counting numbers, plus 0. But it does not include negative numbers, so we're going to skip over that. Now, when we go to integers, it includes all of the whole numbers and their opposites. So if it's natural and whole, it has to be an integer. You can kind of see up here from the diagram. If it's natural, it's inside the whole and it's inside the integers. Okay, so integers have negative numbers, but they don't have decimals or fractions. So we're going to skip over that one. And then this is going to be 0, and 0 is included in the integers. Pi is not because it's an irrational number. 23 is also included in the integers. It's natural, whole, and an integer. And negative 51 now would also be an integer because we could keep going this way. We would eventually get to negative 51. So we're going to check that. Okay, now what I'd like you to do is I'd like you to just kind of put a little squiggly box around this. And the reason why I'm having you do that is because numbers can either be rational or irrational. They can't be both. So you have to choose. Just like up here, it's either rational or irrational. Okay, so let's look at this. The only numbers that would be irrational would be the ones that do not terminate or do not have a repeating pattern. Anything that is natural, whole, or an integer is a rational number. So if we're looking down here, we have an integer here, integer here, integer here, integer here. And then if I look at this number, this one terminates. So it's going to be rational. So let's go back up to the top here. We have 8 divided by 4, that's 2. So it's a rational number, it terminates. This also terminates. This terminates. This does not terminate, so it is irrational. This terminates, and this terminates. So we only have one irrational number there, and that is pi. All right, let's look at the next page. We're going to do a few vocabulary words, and then that'll be it for this video. Okay. An element is an item in a set. So let me just do this here. I have this one filled out. An element is an item in a set, and a set is a collection of items called elements. A subset is a set whose elements all belong to another set. And an empty set is a set that contains no elements, which makes sense because it's empty. You can either represent that by a 0 with a line through it or a slash through it, or with braces and nothing inside. Okay, a finite set is a set with definite number of elements. And then an infinite set, and you might want to underline this infinite, I don't believe it's underlined on your notes, is a set that has unlimited elements. Infinity. The way that we represent infinity is by, it kind of looks like a sideways 8 here. This is positive infinity, this is negative infinity. Now, sometimes you might see people write positive infinity, and that's okay, but if there's not a sign in front of infinity, it always refers to positive infinity. Okay, that's the end of your first video.